This is the fourth video in our series showing how to display video on the Commander X16. In our last video, we saved the tile map and we saved our two lookup tables. We started doing some assembly language code, set up all of our file names. In today's video, we're going to finish all of our file handling subroutines. We're going to save the default palette. And we're going to start setting up our interrupt subroutines. We have a custom interrupt request handler. We have to set that all up at the start, and we have to reset everything the way it was when we're done. So let's get right into it here. Let's load up the file we saved last time. Okay. So here we go. Okay, the first thing is down here we've got a short subroutine that sets the tile map file name. I want 4 more subroutines just like it to set the file names for the other 4 types of file names, and I want to put that right after TFNM. So I've got some data tables that are stored at 9000, and I don't want to overwrite that, so I'm going to just let the editor know that the end of my file is actually right there by typing FEND. Let's put a comment here, save tile map, and I'm just going to insert. I got TFNM is a 9-byte subroutine. I want to do 4 more just like it, so that's 36 bytes, and in hexadecimal that's 24. Okay, so now I can copy TFNM over and over again, 9 bytes at a time. What is that? 0898. 9 bytes. Copy TFNM. And okay, good. So if I go to TFNM now, you can see it's followed by 4 more just like it. So I'm now going to set some new labels here. This one will be for the source file, source bitmap file. This one will be for the palette, or for the audio file. Oops. This will be for the palette file. And this one will be for the video image file. Okay, so now I've got to change all of these. So instead of pointing to T file for these 3, it points to S file. Instead of T file for these 3, it's got to point to A file, etc., etc. So I'm just going to pause here. I'm going to change all of those, and I'm going to change the comments, and you'll see the results in a moment. Okay, with that done, now I can continue on with our programming. We've got the smap function, which we used to save the tile map. We don't actually need this anymore, but I'm just going to leave it in here. The next thing we want to do is have a function that loads the tile map into Vera. And look at the Vera memory map. We can see that we want to load that tile map starting at 04000. So let's do that by first of all setting a label. We'll call it lmap and put a comment in. And we want to first of all set our logical first and second to 180. If we just go to LL, you can see that's exactly what that does. Okay, and we're down here. Next thing we want to do, set the tile map file name. And now we're loading this into Vera. So we're going to load A with the number 02. This tells the kernel that your load location is video RAM, the low bank. If that was 3, that would be the high bank of video RAM. If that was 0, that would just be regular RAM. Next, we load X and Y with the low byte and high byte of the location. And we jump to load. And that's it. That should load our tile map into Vera. Our next thing, we want to be able to load our source file, our source bitmap, into memory. So here's our memory map. We want to load our source bitmap file starting at 6FCC. So to do that, we'll go back in here, we'll set a label. This is, let's call it LSRC. That'll load our source. We want to store it at 6FCC. So first thing we have to do is open a channel for loading. And then we have to set the source file name. So SFNM. And now we want to load it at 6FCC in RAM. So we load A with 0, we load X with CC, and we load Y with 6F and jump to load. So right now, if we go to our source file name, S file, we can see that's our source bitmap file name. I'll just hit F5 and just to recall what it is, SWARS raw C256 image 0001.bmp. So F1, go back. Alright, so we've got a file name set there already. So if I just exec LSRC and go to 6FCC, we can see the header for that file. Hit F3. So the first 52 bytes here are the last 52 bytes of the header. And we'll just go to here, F3. So this is our palette data. You can see blue, green, red, and alpha. Blue, green, red, alpha. So there's 256 entries like that, each 4 bytes. And if we scroll down here, so that's 4 pages of RAM. Just keep scrolling down. That ends at 73FF. So starting at 7400, this byte here is the bottom left-hand corner of our image. It's just an index into that color palette. Color 1E is the bottom left-hand corner, and then it just goes to the right. The first 160 bytes is the bottom row, and then starting here, this is the second row from the bottom. So we have successfully loaded a bitmap file into memory. So now we go back and we can see we're getting close here, starting to get close to our lookup table, which starts at 0900. We better add some labels to this as well. This is the low byte of our column offset. And if we go F3, we can go down to the next part here. This is the low byte of our row address. Hit F3, go down here, hit F1, and this is the high byte of our column offset. Hit F3, go down to B0 and hit F1. This is the high byte of our row address. Okay. So now let's go up into 0 page again. See, we've got 2 labels here already. We're going to add a couple more here. Row number, set another label here, column number. So now we got 4 labels here in 0 page. So now if we go back, let's go to LSRC. There we go. So from E6 to FF, that's all we've got left. So we'll go to the start here, all of our file names. S file, the numbers here, these are all in decimal. But if we go further down, past our tile map file name, this is our audio file name. Now all of these are in hexadecimal, so we have to be able to take hexadecimal. We have to be able to take a number in the accumulator and convert it into 2 hexadecimal characters that we can plug into the appropriate locations in A file and P file and V file. So that way we can update the file names as we're scrolling through the list. In order to do that, we're going to need a subroutine that can take the accumulator and convert it into 2 hex digits. So if I go F1 here, I've got this string here of 16 hex digits starting at checks. So if we go to LSRC again, I can write another little subroutine here. I'll better put a comment in here. Okay, and let's put in a label here. We're going to convert accumulator to 2 hex characters. So first thing we're going to do here is transfer A to Y just to save it. We're going to AND whatever's in the accumulator with F0 to isolate the high nibble, and we're going to shift that right 4 times. Transfer that to X, and we'll load a value in that C hex table. Transfer that back to X. And we'll transfer Y back into A and it with 0F to isolate the low nibble. Transfer that to Y, and we'll load another value in that C hex table, and we'll transfer that back to Y and return. Now we didn't really need to transfer that character back into Y, but oh well. So now X contains 1 character, Y contains another character, and A also contains that second character. And we're left with 5 bytes left in this page. So that's a pretty good place for us to stop for right now. I'm trying to keep these under 15 minutes, so there will be another video right after this one. So I'm going to, not going to save yet. I'm going to go to 0B00, set my file and go back, and we'll save swars.prg. Yes. So we'll end this video here, and I'll see you in the next video shortly.